your attention now. Today's topic is free fall, and technically an object is under free fall if only it's being pulled by the earth. So this lovely thing, not so much the earth, but the force of gravity. If it's only being pulled by the force of gravity, then the object is in free fall. So all of our problems will assume that we have no air resistance, because air resistance actually, if I'm being pulled down by gravity, the air is actually pushing me up and slowing me down, but we're in free fall. So there are a few things that we have as assumptions. So one of the assumptions that we have is that our acceleration is either a positive or a negative 9.8 meters per second. And therein lies our biggest problem with these problems is when do I use a positive 9.8 and when do I use a negative 9.8? Acceleration is a vector. So being a vector, it has direction, and its direction is always down. Always, always, always down. Okay, so we're also going to be using our same kinematics equations that we were using before. So we're going to use x equals 1/2 at squared plus v initial t, and we're going to use v final equals v initial plus at, and we're going to use v final squared equals v initial squared plus 2ax. So those are the equations that we have from before, and we're going to use those same equations. One of the things we're going to do with them is our acceleration and our velocity are going to determine what sign we're going to use, if we're going to use a positive 9.8 or if we're going to use a negative 9.8. So if we're going to, let's say we drop an object. Okay, if we drop the object, what's its initial velocity? Remember from before that if we drop it, our initial velocity is 0. So its velocity, it doesn't have one right as it leaves our hand. And so we can go ahead, since this doesn't have a direction, 0 doesn't have a direction, we can go ahead and use the positive 9.8 meters per second squared. Okay? If we throw something down, then our initial velocity is in the downward direction. Well, which direction is our acceleration? Remember, our acceleration is also in the downward direction. So it would make sense to make positive down. In this case also, we can use a positive 9.8 meters per second squared because our acceleration and our velocity are in the same direction, so they can have the same sign. So if we're going to use a positive velocity, we can make our acceleration positive also. If we throw something up, though, this is where we run into issues. So if we throw something up, then our initial velocity is in the upward direction. Our acceleration is still in the downward direction. And do you see how they're in opposite directions? So if they're in opposite directions, they need opposite signs. They need opposite signs because there's a very important idea here. But let's go ahead and write down our acceleration is going to be a negative 9.8 meters per second squared. So this is pretty much the only time we're going to use a negative 9.8 for our acceleration due to gravity. So our very important idea that we need to know is that positive and negative in physics shows direction. So if two things are in opposite directions, they need opposite signs. If they're in the same direction, then they can have the same sign. So let's go ahead and type that out. So opposite directions, opposite signs, same direction, same sign. This idea is hugely, hugely, hugely important, and it is going to come back many, many, many times throughout the year. So that's something you really, really want to star, highlight, put on your equation sheet. Use this a lot. And okay, so we got a couple more assumptions. So we have part 2 or part 2 for those of you that are in French of our assumptions. And that would be if we consider the flight of an object when it goes up and when it goes down. Okay, so its initial velocity is in the upward direction. Gravity is always down. Nobody turns the Earth off. So gravity, the acceleration due to gravity, is going to be a negative 9.8 meters per second squared through the whole flight of your ball, or whatever it is you're throwing up in the air. It's always, always, always going to be accelerated at 9.8 meters per second squared, which means that every second it's going to lose 9.8 meters per second until up here at the very top it's got to go stop. Right here your velocity is 0 meters per second. So in an equation we would make this v final. So that's an important idea to remember, and that's an important kind of assumption to make, is that your velocity at the very, very, very top, so it goes, stops, turns around, comes back, but it's changing its velocity at 9.8 meters per second squared. So on the way up, it's decreasing. On the way down, it's increasing. But the reason why it's increasing on the way down you have negative velocities. And so you can see that your velocity and your acceleration are both negative. So if they're in the same direction like these guys are, they're helping each other. Here, our velocity is positive and our acceleration is negative, so they're hurting each other, and they're in opposite directions here, so they're going to hurt each other. And so that's why it slows down on the way up, speeds up on the way down, but the acceleration is still this negative 9.8 meters per second squared. Nobody turned the Earth off. It happens the whole flight of the ball. So don't get suckered into choosing the at the top, because that's a sucker answer. There is another point that we know its velocity, and that's right here at the bottom. Okay, at the very bottom, when it gets back to the spot where it started, its velocity, its final velocity, is the same. The speed is the same. The velocity is just the same magnitude. So this part, this part here is the same as this part here. Just it's in the opposite direction, so it has that opposite sign. And that's also going to help you solve some of your problems, is knowing that the final velocity down here at the bottom is the same as what it started with. So you know in those cowboy movies, so these assumptions, you're going to add to the assumptions from the previous video. They're not going to be stated in problems, so you just need to say, okay, the velocity at the top is 0. One other thing, there was one other thing I needed to say, and that has to do with the time. Okay, so how do you think the time to the top compares to the time to the bottom? Right, the time to the top is the same as the time to the bottom. Okay, so it doesn't really matter which half you're talking about, the time is going to be the same. And how do you think the time to the top compares to the whole time? Right, this is half of the whole time. So the time to the top is half of your whole time. That's something you may have to pay attention to in some problems, because you may calculate this whole time, but then you want to know how high it is. And if you want to know how high it is, you want to use just half that amount of time, because that's where it is at the top. So we're going to apply this tomorrow. Good luck, and I will see you later. Bye-bye.